Okay, so who is absent today? I still can see no faces. Maybe you others? Last week I need to finish another. Okay. I should There's no attendance in the office. So yesterday's one. Let's see this yesterday. I get it from the there's a printed one. So just okay, today also you guys try. So later on you get from me. You coming to faculty later? Got anything to do there? Tomorrow now. You come to my office. Okay, that is this one I keep on. Or you still want to sign? For today. Okay. Okay, another 2 more lectures with me. Okay, 2 more lectures with me. Okay, after that, Dr. Hira will continue. Right. Okay, so today is underground water and contamination. So now after this class, we finalize also the group members now for the composting. Okay. So, still anyone? I don't know, right? Why? Okay. So you see composting groups. Okay. I think some of you say group not enough people or extra people. Extra people like 6 people, right? Okay. So if 6 also can, no problem. Okay. Just I don't want more than 6 now. Standard 5. Standard 5. Okay. So what do you guys understand about underground water? And then nothing to do. You remember also?
I'm the one that just now messaging you, right? The guy that saying that 450. So later I can meet you here for the. Yes, sir.
Okay. Contaminated land and bioremediation. Okay. There's a lot of this slide got a lot of words. So before we go to the slides, okay. Let's see what you guys understand about bioremediation. Come on. Anything you just tell, no problem. Okay, what is bioremediation? Bioremediation. Any idea? No.
Like place already like contaminated or like pollution, and we're trying to reverse the contamination.
Okay, contamination. Reverse the contamination. Okay. Any ideas? Sure.
China no bioremediation.
Are you sure? Are you sure China no bioremediation?
The part where I live lah.
Everything clean lah in China. Are you sure?
No. I need to say yes if not my social credit drop.
Okay, so bioremediation is very simple. Bioremediation is anything that contaminated. It can be any place in the world. It can be sea, it can be river, it can be soil, underground water, anything that contaminated, we reverse back. Or we cure the contamination using what? Biological things. Like mainly microbes. Okay. Not bio means not only we are using microbiology or microbes. You can use chemicals, you can use any kind of bio related things to cure the condition. That's all. Okay. So in this topic, what we're going to learn is two things. One is contaminated land, soil, in land, and soil. And another one is underground water. Underground water. Soil means what you just understand about the soil. Soil consists of few layers, like not okay. On top is the top soil, then go to the bottom layer, there's another layer, okay, bottom layer, humus, and then rocks, silt, clay, and so on. Okay, so there's a lot of layers. So we go through about the layers of the soil, okay, and then what layer will be contaminated and how we can cure the contamination. Okay, and when it comes to underground water, okay, underground water. What is underground water? Any of your accounts for underground water? Don't say China. Underground water. What? Where? Not enough. Okay? That is underground water. Okay? You know, bore, B-O-R, like boring water. Okay? In villages they do the boring. So that is underground water. Okay? So underground water is there's not what we understand is underground water is just kore-kore lubang or it's underground water. No, not actually. So underground water also it can be divided into underground water from confined space and unconfined space. So there's a lot of categories. So later you will see what are the categories of underground water. Okay? So that's it. So underground water also can be contaminated. How? Right? Yes, you're using the chemical fertilizer. Chemical fertilizer is mostly it will be contaminated on the surface sector. Like for example, when it involves like a petroleum, we are taking the petroleum and so on. Okay, where we dig the soil, okay, until the few meters inside. Okay, then the underground water will be contaminated. So underground water is actually where we can find the underground water. Actually, the underground water is not exists as water. Okay? It exists in between the rocks, in between the pasir, okay, and so on. Okay? The gaps between the rocks are very minor. Okay? And these gaps are holding the water together. You understand? So that is underground water. Okay? So if you see like some companies they are doing some project taking the underground water. You drink the mineral water, you drink it not. Some are drinking water, some are underground water, some are RO water. Okay, there's a lot of categories. So the underground water is taken from the underground. So that's the same. So I think that in Tupa also there's an underground water. Correct or not? Okay. You know Tupa? So is there any technology in China? How do you take underground water?
I think they
Why I'm interested in China, you know. China got very, how to say, many kind of machines. Okay, you can get it from China. I always like to see the machineries and equipments from China. You can find many different kind of machines in China. Okay, the market is very wide. Okay, if got opportunities, both of us will go to China. Okay, so that's the thing. Okay, the slide here is very, how to say, very complex. Okay, very complex. There are a lot of details. So okay, there are a lot of details, a lot of wordings here. So I won't go through one by one. I think now it's almost 3 o'clock. If I meet one by one, I think all of you will sleep already. Yeah? Okay, so I will just touch the important points. What is the important points? And you can read all the points one by one. Okay, I will just touch the main points. Okay, so I think the main point is enough for you to understand. Okay, okay, Mom. Okay. Can I see? Can I see? Can. Because the PC is like difficult to control. If I got the pointer means easy. Any of you got pointer? Okay, never mind. I myself. Okay, the soil texture. Okay, the soil are complex mixture of mineral, water, air, and organic matter. Okay, the soil consists of many components. Okay, the main three components are sand, silt, and clay. These are the three main components. So you can see here the texture of sand, silt, and clay. So these are the components, the main three components in the soil. So you can see the clay. Okay, the clay. The size of the clay is the smallest. So it's the smallest. The silt, medium size lah, 0.002 to 0.05 mm, and the sand is a bit bigger until 2.0 mm. Okay, these three things are the main component of our soil. Okay, so how you want to know your quality of the soil? So this is the pyramid. Okay, this is the pyramid, the soil texture triangle. From here you can know what kind of soil that you have. Okay, so the USDA classifies soil types according to soil texture triangle chart. Okay, see the main three components: clay, silt, and sand. Okay, these three things are here. So based on the percentage here, you can identify your type of soil. Okay, for example, you see, how do you read the triangle? For example, you have 15% 15% soil, clay 20%, clay 15%, silt 20%, and sand 65%. So how to read? Okay, you see here, soil 15% clay, where's clay? 15% clay. 15% where? Over here, here, right? Okay, then 20%. Okay, just directly go for 20%. 20%. Okay, where's 20% over here? Okay, 10, 15 here, 15 is here, then 10 is here. Right. Sorry, 20 is here. So, and then 65. So is 15% clay, 15% clay, 15% clay, 15 is here, right? Correct, right? Okay, here. And then 20% here, 20% here, 20% is where? Is here. So 20% is over here, and 65% of sand. Okay, it should be here. So it should be here, here. Okay, by that it should be 15 here, 5. 65 is where? Oh, sorry, 20% is here. 65% is here. 15, 65, 15, 65, and that's quite complicated, Just now when I did is correct. 15. By that it should be how, you go 15%, okay, you go 15%, and silt is 20%, and 65% is should be like this, okay, but it's okay, okay. I will give you this solution. I will give this solution. Just now when I see is correct. Sandy loam. Oh, you guys got any other thing? Oh, is it? Sandy loam, right? 15. Oh, correct. So it's a 15, right? So it's a 15. And say this 20, say this 20 is here. Okay. So it's 15, 20. 65 over here. Correct, right? 65 is here. It should cross. It should cross. All these three things should cross together. 15. Somewhere here, correct? Sandy look. Correct, right? That's why when I do this one, I got sandy look. Suddenly. Okay. So sandy look, right? Am I correct? Okay. Oh, you guys got any other side? Any other side? Sandy look. Confirm, right? Okay. Okay. Sandy look. So this is how we use this soil texture triangle. Okay. So all of you clear? So it should cross. It should all these things should cross together. So it's soil like this one clay. It's a 15% over here, and there is 65. Okay, sorry, 20 over here, cross, and sand is 65. So all these 3 points should cross together. Okay. Okay, then you will get the type of the soil. So soil. Okay, everyone is clear? Okay. Next we go to the properties. So soil properties. So properties of the soil. Soil properties, we have a lot of properties like bulk density, the porosity, okay, and like chemical properties we have like electrical conductivity, pH, okay, EC, okay, moisture. These are the chemical properties of the soil. So depend on the layer. Okay, if let's say the top layer is not the same as the next layer, so every layer of the soil will have different soil properties. Like the soil near to the the water table, okay, water table will be more wet, okay, compared to the topsoil. Topsoil is the soil that we have in the top, okay, and that topsoil is consists of like how to say, the organic materials, okay, the undegraded things, okay. For example, like leaves, okay, leaves, all the organic materials without any degradation, it will be on the top. Okay, when it started to degrade, there will be another layer formed on the top. Okay, so what we can say is the soil on the top is most nutritious. Okay, because it full of lot of organic materials. Okay,
so is it like the black soil?
Black soil. Okay, black soil means how?
Like the soil that have a lot of decaying materials, and then it's very suitable to grow crops.
Okay, the soil also is okay. You see, certain place the soil is black in color is because of the content. Okay, the carbon content might be higher. Okay, the topsoil means is not black. Topsoil means is the soil that you can found on the top layer. Okay, so it can be a black color or yellow color or any color. The soil that is on the top. Okay, you go anywhere also, the soil color will be different. Not everywhere you can see the soil is in the orange color or yellow color.
Yeah, some is red color, some is.
Okay, but the topsoil means is the soil that you can found on the top layer. Okay, later I will show you the layer. Okay, so even it's a black color soil, it's still topsoil. Okay, it's still topsoil. Okay. Okay, so soil texture effect. Okay, all these things is the the properties like structure, chemistry, property, and permeability. Soil porosity refers to the amount of or open space between the soil particles. So pore separated by the contacts made between irregular shaped soil particles. So soil, what we see is soil is it powder form? Is it solid? What is the form of the soil? Solid. Solid in the form of, is it powder? What is the structure? What is the structure of the soil? Powder. Okay, there's four kind of structure. Okay, you guys know, right? Okay, four kind of structure of the soil. So we can see here. Okay, this is the structure. Granular, clerical, locky, prismatic. This is the structure of the soil. This is the structure of the soil. So in the individual particles is like what you can see is like small powder form. Okay, then particles aggregate to form pack. Okay, and then pack stack around each other to form soil structure. Okay, so you see these are the four types. So what we know is normally it's a granular, correct or not? Okay, we just see it's a granular. Okay, but soil also in the form of flaky. Flaky means it's like a sheet, lapicine. Okay, it's like a sheet. And blocky structure are soil particles that are cleaved together nearly square or angular blocks. So like a block. The name blocky means it's a block. Okay. Then prismatic. Prismatic is a vertical column or like a pillar. Okay. These are the structure of the soil. Structure of the soil. So bulk density. Okay. What is bulk density? Okay, one of the character you can study during your composting is bulk density. Okay, later on when you do the composting, you have to study also bulk density. Okay, bulk density is the mass per unit volume, including the pore space. So it increases with the clay content. It increases with the clay content. So the greater the bulk density, the more compact the soil. The more compact the soil means there is a lot of clay. Okay, there's a lot of clay. Okay. Next, we go for the CEC. What is CEC? Cation exchange capacity. Okay, cation exchange capacity. So, what is the use of cation exchange capacity? In the soil, there's a lot of nutrients. Okay, cation means what? Positive or negative? Positive, right? Okay, there's a lot of cations in the soil. Like, for example, calcium, magnesium, sodium, potassium. Okay, these are weakly held by the soil. Okay, it's a very weakly held by the soil. So when there's other anion, okay, come in contact with this cation, it can be released easily. It can be released easily. So soil with high CEC is more fertile, more nutritious. Okay, why? Is because there's a lot of nutrients. Okay, nutrients is a form of micro and macro nutrients. Okay, so soil with high CEC are more fertile than those with low exchange capacity. Okay, as we studied yesterday, in a study like compost, the pH range will be 6 to 8, correct or not? The N. So that is suitable for the plants. Okay, and for the soil, generally the acceptable pH is 3 to 10. Okay, and for agricultural purpose, 5 to 7. Okay, near to the neutral, not alkaline or not very acidic. So near to the neutral. Okay, this is the soil profile. You can see the soil divided into many layers. Okay, many layers. Okay, the top is what we call is soil surface. Is called consists of the topsoil. The topsoil. So it composed of undecomposed organic debris and also decomposed organic materials and also humus. So humus is what? Humus. Yesterday you see the compost, right? That is the humus. Humus is the simplest form of organic materials. Okay? Anything that degrade, any organic material degrade, it comes to humus. Humus is the simplest form. It cannot degrade anymore. Okay? Understand? Okay, that is the thing. After that you have few more layers. A-E-E-C-R-A. These layers divided into two layers. Alluvial and alluvial zone. Alluvial and alluvial zone. There is a two. Okay, alluvial is what? Alluvial are layers consisted of geological deposit. Deposit like through the environmental action. Environmental action like weather, okay, like weather, rain and so on. Okay, the layer is formed due to the geological deposits. Okay, and down there alluvial is how? Okay, alluvial zone refers to the layers where material is displaced across a soil profile from one layer to another one by the action of rainwater. Okay, so the rainwater go from top surface to the alluvial and at last alluvial zone. So at the bottom there you can see the hard bedrock. Okay, before that you can see the underground water. Okay, before the hard rock you can see the underground water. Okay, so you can see here a layer, a light colored layer representing zone of maximum leaching, maximum zone of accumulation of weathering products such as silicate, clay, iron, okay, and relatively unaltered, unconsolidated parent material. So every layer the contents are different. Okay. And this layer in the alluvial and alluvial zone there is underground water. Okay, there is underground water. And this underground water is separated by two types: confined underground water and unconfined underground water. And between these two layers there is a clay formation. Okay, so that these two mixtures not, how to say, not mixed together. So when you want to take the underground water like well and so on, you go deep into the confined underground water. Okay.
So usually from the most top layer until the most bottom layer, usually how deep is it?
How deep is it?
Yeah.
Wow, there's a many kilometers now. Human just reach few kilometers away. Okay, there's a very deep inside. Very deep inside. Okay, so I do not know what is the exact how many kilometers. Okay, the deep until the core. Okay, that is very deep. Okay, we cannot reach until that deep. Why?
Pressure.
Pressure and heat. Okay, if not mistaken, the human only able to reach until 12 kilometers. That is what I
That
know.
one is from the Soviet Union, right?
Yes, Russia.
Yeah.
Okay. Okay. So that's the thing. Okay. If you want to try, can. Okay. 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 Oh, we come to a bioremediation very. Okay. Bioremediation. There's a two bioremediation. One is in situ. Another one is ex situ. In situ is what? In situ. In situ. Situ. Okay. In situ means that at the place. Correct lah. In situ at that place. Ex situ is ex away. Okay. Exit. Exit. So ex situ means away. So let's say the soil contaminated already. We take the soil, we bring to another place. We want to treat the water. We call it ex situ. If we treat at the existing place, that is in situ. That's all. Okay. So normally we prefer at the site in situ. Okay. the side and away the side. Okay, so there are 5 methods. Okay, sorry, 6 methods. Okay, how we keep ex situ. Okay, so biopile, land farming, soil washing, white rot fungus treatment, slurry phase bioreactor, and composting. These are the ways that we treat contaminated soil. Okay. Biopile is exactly like yesterday. You remember windrow composting is like that. Okay, we just take all the contaminated soil, we pile them. That is what we call biopile. Okay, biopile. Okay, biopile. So we pile up all the contaminated soil and then we give the aeration. We put the microbes. We treat the soil. That is a biopile. Okay, see here. You see? This is how they do it. Okay, there's an aeration pipe here. Okay, so in a control, ex situ short-term technology used for converting contaminants to low toxicity byproducts. What they do, they extruded soils are mixed with the soil elements formed into compost piles and closed for treatment. Okay, and biopiles are designed to provide optimum temperature. It's exactly the template of composting. Okay, just we replace the compost, the organic material with the soil. And what they do also is adding compost to the contaminated soil. Why? Why? Because compost consists of lot of microbes, correct or not? Lot of microbes, lot of nutrients. Okay, the soil already contaminated already. So now what you have to do? The patient admitted in the hospital. What do you need first? Okay, you will give them the glucose, correct or not? Why? It's because provide the energy. Without energy, cannot. The first thing you have to give them the glucose in the form of energy, correct or not? So the same thing. The soil already contaminated already. If contaminated means how? The soil contaminated. Might be contaminated through chemicals, correct or not? When you expose the soil to the chemicals, what will happen? The microbe might die or not? Correct. Okay, there won't be any microbes in the soil because it's already contaminated already. So now you give some good food. The food is in the form of compost. Okay, that is the biopile. Okay, you can see here. Okay, so basic biopile system. Okay, is the treatment where you give the aeration, you give the nutrient system, and then of course the important thing is the leachate. You know what is the leachate? Leachate. You know, leachate is the water leaking from the pipe. Okay, you cannot leave the water stagnant in the system. Okay, you have to remove the leachate. Okay, when you do the compost, you can go through the word compost tea. Compost tea. You drink the tea, TEA, we call it compost tea. The water coming up from the compost, we call it compost tea. But don't drink that tea. That tea is, okay, that tea is only for the plant tea. Okay, plant can drink that tea. You can drink that tea. Okay. Later on you can collect the tea also. Okay. That's a good question. It's a good question. If you drink, you will be admitted. That's all. No, you will be admitted. Yes, because the liquid is actually will be full of microbes. Okay. So if you drink it, of course you will be admitted. Okay. So that is the biopile. Okay, you can see the biopile here. Okay, so you can see the point over here. So typically operated so that material temperature rises as a result heat released by biodegradation. It usually operates in the mesophilic range. The biopile do not reach until thermophilic. Okay, thermophilic heat is a 45 degree and above. Okay, so this biopile controlled in the mesophilic range, which is below the 45 degree Celsius. Okay, then of course fertilizer is added to the soil to provide optimum balance. Okay, carbon, nitrogen, and phosphorus. Okay, and bulking agents may be required if the soil porosity is low. Okay, so that bulking agents, you know, right? What is bulking agent? But bulking agent is any type of materials you add to soil or compost to make it solid. If not, it will be soggy. Okay, like compost, you add what? Bulking agents, dry leaf, okay, fibers, papers, cardboard, eggshells. Okay, you add this thing so that the compost do not become soggy.
So can we add clay inside?
Hmm?
Can we add clay inside
Clay inside what?
the soil?
Clay. Maybe not.
Okay.
Okay, because what is the purpose?
Because just now said if the soil has more clay density, they contain more clay, it will form more to like a solid form.
Okay, so you can add the clay, but the thing is, the clay, that is the bulk density. Okay, bulk density. So if you add the clay, the oxygen will be limited because clay the oxygen cannot pass through the clay.
Okay.
Okay, so it will be very compact already. So no point we add the clay. Okay, so the next biopiles. Okay, there's so many methods here. Okay, I don't know how you guys going to memorize. Okay, okay. So applications. Okay, biopiles commonly used for volatile organic compound and few contaminated soil. Okay, the limitations. Okay, what are the limitations? Every this step, bioremediation step, will have its limiting factor. Okay, for example, here very high contaminant concentration may be toxic to microorganisms. Okay, and this biopile will consume space. Okay, will consume space. And before you treat with biopile, you have to filter them. Filter them means that materials above 60 mm you have to remove. Okay, 60 mm you have to remove prior for the treatment. Okay, same goes to your composting later. Okay, you have to make sure your materials that you use for the composting are cut into small pieces. Okay, don't just take the full paper and throw into your compost pile. Okay, okay, that is the limitations, some of the limitations. Okay, then land farming. Land farming, what is the method? Just korek saja.
Slow and then
Just korek saja. Okay.
cultivate.
So on the top layer, you just korek. Okay. Or you just turn. Okay, using the the tractor. Okay, normally you see the savapadi on
Mowing?
how they turn.
Called
Just
mowing.
pushing that. What is the purpose?
Power.
To turn the soil. When you turn the soil, what will happen? There's more oxygen going inside. Okay? There's more oxygen going inside. So
Oh.
those microbes can survive better. So that is the purpose. That is land farming. Okay? So contaminated soil, sediments or sludges are turned over. Okay? And allowed to interact with soil and climate at the site. Okay? So the way soil, climate, biological activity interact dynamically as a system to release, transform and immobilize. That's the okay, just the so that is the actually all the thing that you are learning here is actually we are practicing already. But we do not know the actual name, actual scientific name. Okay? We just say land farming, we think it's very complicated, but in the daily life, in our paddy field, we are performing the land farming. Okay? Okay. So the duration of operation land farming is dependent on cleanup goals, the concentration type of contaminants, Okay, and also depends on the climate. Depends on the climate and degradation rates and dyeing frequency. Okay, this method is suitable for what kind of materials, what kind of contamination is non-halogenated volatile organic compound or semi-volatile organic compound contaminations. Okay, so every method, okay, we cannot use the same method for all kind of contamination. Okay, for contamination involving non-halogenated volatile organic compound or semi-volatile organic compounds, we can use the blend farming method. Okay, of course, there's some limitation for this method also. The first thing, not suitable for treating hazardous or toxic contaminants. Okay, so toxic contaminants we cannot use land farming method. Okay, and this method also will consume space. Okay, will consume space. Okay, so the runoff collection facility must be constructed and monitored. So of course the contamination. Okay, when we do the treating the soil which is contaminated, we also need to make sure those contaminants are properly handled. Okay, you understand? Like for example, when there's a you want to land farming, okay, you use water, okay, the leachate, can you just release to the public drain water? So there's limitations. Okay. So you must make sure the running of water or the leachate are properly diverted to the proper destination. Okay, understand? Okay. So soil washing. So this one how the method? Just like a washing machine. Okay, just like a washing machine, you wash your soil. Okay, the contaminated soil will be washed. So it's an ex situ physical chemical treatment involving scrubbing soil with a water-based wash solution. So how they do it is, okay, vigorously agitating to transfer contaminants into the wash solution, separating the soil and solution and treating the solution. So same thing, how you wash your clothes using washing machine. Okay, put inside the water and then the dirt all will go off and you take the cleaner.
So what does vigorously agitating mean?
Okay, agitating means, agitating is pushing. Okay, it's like a spinner. Okay, agitating is just pushing. You see mixture here? Here, the mixture here, the inside, like the ribbon here, this is the agitator. This is the agitator. You can read about bioreactor, right? Inside the bioreactor, there is an agitator, correct or not? That is the agitator. It's a mixing. Okay, so it's a agitating is just a mixing. Okay. Okay, so the process remove contaminants from the soil by dissolving or suspending them in the wash solution. And what will happen? We will release the contaminants into different passage and we take the soil. But the thing, the limitation is the water content. Okay, you can see the fine soil particles, okay, may be difficult to separate. It's because wet, correct or not? Okay, it's difficult to separate. Once you mix like that, okay, you cannot take up 100% of the water from the mixed solution. It's very difficult. Okay, and the clay and cubic materials tend to retain contaminants. Clay is very hard. You cannot wash inside the clay, correct or not? So clay materials difficult to wash. So that is the limitation of this method. Okay, white rot fungus treatment. White rot fungus. You guys know? White rot? No. No, okay. white rot fungus treatment involves using fungus to biodegrade organic contaminants in the soil by secreting useful enzymes such as lactase, manganese peroxide, and lignin peroxide. Okay, so what they do is mixing the contaminated soil with the white rot fungus. So this fungus will degrade the contaminants. So this is one of the methods. So you can see picture here, all the contaminated soil will put inside the mixture and also the white rot fungus. So the white rot will degrade all the contaminants. After that, the treated soil will be cleared off the contaminants. That is the white rot fungus treatment. Okay, so the limitation is what? The limitation of this method is the naturally occurring bacteria. Okay, in the soil there is a lot of bacteria. Okay, so white rot can fight with the naturally existing microbe or not? That is the question. Because if it is competitor, then the method won't be effective. Okay, that is the limitation of this method. Okay. Slurry phase bioreactor. Okay, this one is almost similar as this method, soil washing. Okay, almost similar as soil washing. Okay, so the slurry phase biological treatment involves a controlled treatment of a fluid mixture of water and exaggerated soil in a bioreactor. So just now you asked, right, agitating. Okay, this is the agitating. This is the bioreactor. Okay, so the contaminated soil will be put into the bioreactor to decontamination. Okay, so the extruded soil is processed to physically separate stones and rubber and mixed with a predetermined amount of water to form slurry. So sometimes the soil is processed to concentrate the contaminants. Okay, to concentrate the contaminants, and they will put into the bioreactor to treat the contaminants.
Different from the soil working is bioreactor and the other one.
Bioreactor is closed. It's a closed system.
So this one is more expensive compared to.
Yeah, bioreactor of course expensive. Bioreactor of course expensive. Okay. I'm going very fast is because there's another lecture. Underground water. Okay? Okay? I hope you guys don't skip now. Okay. That's why I'm just picking the main point only. Okay? Because the time given for me is just 4 lectures only. So I have to finish everything. Okay? Today is second lecture, so got another 2. To do another 3 more lectures I think. Try to finish. All these must be covered for your CA. No shop. Or you want me to make this one more simpler? You want me to redo this slide? Is it complicated?
Okay.
Okay. Expensive. See, never mind. Don't worry. We got the tutorial. I think there's a tutorial, so I'll try to simplify this. Okay? But I will send this slide today. Okay? The composting slide and this slide I will send today. Okay? So this is slurry. Okay? So the soil is maintained in the suspension. Okay? Okay, so for this slurry also, we might add the microorganisms. Okay, microorganisms, and also we can add nutrients. This becomes a bioreactor system, so we can add nutrients, we can control the pH, okay, we can treat the soil. Okay. So this is the processing rate is depends on the following. Okay, clean up those, the concentration of the contaminants, temperature of the reactor, okay, nutrient concentration and proper aeration. So this is the example you can see here. Okay, this is not small. Okay, this is the bioreactor. Okay, this is the bioreactor. Okay. Okay. So the limitation is the very high contaminant concentration may be toxic to microorganisms. Okay. So dewatering soil fines after treatment can be expensive. Okay. After using the bioreactor, so all the contaminants, to treat the contaminants is very expensive. Bioreactor itself is expensive. To treat the contaminants is also expensive. Okay. No, it's not good. Well, finish already. Okay, now only 30 slides. Okay, finish already. So what I want you guys, okay. So we make it very simple. Okay, what you need to focus. Oh, wow. What? Focus. Okay. Of course, because I understand. Okay. So too much maybe. So okay. You just take note. Okay. What kind of bioremediation techniques we use to treat contaminated soils? What are the bioremediation techniques that we are using to treat the contaminated soil? The techniques is now which I show you to use 6 methods, right? Right, 6 methods. You just find what is the definition of the definition. Is it using a book, a microscope? Is it using enzyme? Is it using any kind of bioreactor? And then the thing, what kind of contaminations we use that method? Just now we see that. Okay, I show you. Okay. For example, you can see, okay, application for what kind of contaminants? Is it like VOCs or non-fluorinated volatile organic compounds? And then limitation. What are the limitations? What are the problems? Limitations are so many here. So for simple, what are the method? For what contaminants we use? What is the limitations? That's all. Okay. So for 15 marks essay questions, you can write 3 techniques. Three techniques is definition, and what are the contaminants, and what are the limitations. That's all. Okay. Sorry? No, like case, just give me. If you want to see it, 15 months also can. Okay, so it's very, I want you guys to just focus on this. Okay, come, okay. Slide fast. Anyone want to go for toilet? Or you want to take 5? You want to go China, friends? Oh, continue. Continue, huh? Okay. Okay, still taste off, still fresh. Okay. Okay, groundwater. Okay, groundwater is the water that is held within the interconnected openings of saturated rock beneath the land surface. That's all. Okay. The water you can find in the between the gaps of the rocks underground. Okay. That is the you might think that how the water can be stored between the rocks. It's all you study the intermolecular connection, the forces, intermolecular forces. That's all. That's the part. Okay? That is how water is poured in between the holes. Okay? Okay. Groundwater underlies Earth's surface almost everywhere. Okay? Everywhere. Okay, you correct everywhere also. Up, down to certain limit, you can find the water. Okay, you can find the water. It is the primary source of drinking water. Okay, so the water that you see in the river, sungai, everything is from the underground. Okay. Okay. So which visual is given? So you can see there's a blue color line here. Blue color line here. Okay, that is what we call water table. Water table. So below the water table is what we call underground water. Okay, below the water table is the underground water. Okay, so that's all. Okay, that is the underground water. So from where the underground water come from? Everything from the rain water. Okay, rainwater. So you can see here. Okay, there's a Vados zone. Okay, Vados zone. Okay, this Vados zone, okay, is a very important zone. You have to know. Okay, just I give some hints. Okay, just take note of this slide. Okay, take note of this slide. It's a very important slide. Okay. Okay. How groundwater formed? See, the precipitated water must filter down through the Vados zone, in which the zone of saturation where groundwater flows first. So any rainwater, anything, it must pass through the Vados zone. Okay, Vados zone, it must pass through the Vados zone, go to the passing through the water table, then to the saturated zone. In the saturated zone, we can find the ground water. Okay, so the water zone includes all the material between the Earth's surface and the zone of saturation. Okay, so the near the upper boundary of the zone of saturation where the water pressure equals atmospheric pressure is the water table. So you have to know what is water table, what is water zone, what is saturated zone. Okay, remember water zone, water table, saturated zone. Okay, so water zone has an important environmental role in groundwater system. As with water, surface polluted must filter through the water zone before entering the zone of saturation. So any contamination, if it does not pass through the water table, the underground water still safe. If it is already passed through the water zone, already passed through the water table, means that your underground water is at risk. Okay. Okay. So you can see here clearly. Okay, water table. Okay. The purple color is all groundwater. Okay. And the line is water table. And above there is unsaturated. Is a Vados zone. Okay. Okay. We move to another important term, aquifers. Okay. So aquifers is an underground layer of water bearing permeable rock. Okay. Rock fractures or unconsolidated materials of which groundwater can be extracted. Okay. Just now we see water table. Below the water table is the underground water. Right? Huh? Okay. The underground water, okay, because it's a confined aquifer. Okay. Aquifer is an underground layer of water bearing permeable rock. So to be an aquifer, the store water must be accessible at a usable rate. Aquifer can be confined or unconfined. Confined or unconfined. Okay. Just now I told you, right? Okay, there's a two layer, confined and unconfined layer. And between these two layers there's a clay. Okay, there's a clay. So that the two layers does not mix. Okay. Okay, confined aquifers have non-porous layers above and below the aquifer zone. The non-porous layer hold the water, restrict the water movement. Okay, restrict the water movement. Such layers are referred as the aqueducts. Okay, this is the aqueducts. of the water movement. Okay, so clay soils, shales, and non-fractured weakly porous, igneous, and metamorphic rocks. Okay, rocks or sedimentary rocks, but has been changed as a result as the intense heat of pressure. Okay, examples of aqueduct. So this layer, okay, we no need to remember so much. Okay, the layer between unconfined and confined layer is the aqueduct. Okay, is the aqueduct. So an unconfined aquifer on the other end does not have confining layers that retard water. So the unconfined aquifer is above. So above there's nothing blocking like the aqueduct. It's only between the unconfined and confined area. Okay. Okay. Aquifers. Okay. Some aquifers are confined under pressure. Okay. So this means the groundwater is under positive pressure and therefore doesn't require a pump to bring to the water surface. Okay, you see the sometimes some well, okay, okay, you can see the water is, you don't need to dig anything. The water will automatically coming from the ground. Okay, so that is the groundwater recharge. So it's just coming. Okay, it's like some place you have to dig, correct or not? Some place you have to dig. Some place the pressure favor the water flow. So it automatically it comes to the surface.
Also, if the well already depleted means the area the pressure no more.
Yeah, the well is different. Well is you have to dig. But this term, okay, this term is special. Okay, this one is a special. It won't occur in every well. It's certain well, you see certain well, the water will overflow from the well. You got see or not? You never seen it before. Certain well, the water will overflow from the well. Okay, that is the pressure. Okay, the pressure favor the water flow. So that is why the water can overflow from the well. Okay, so sufficient pressure results in free flowing water. For example, you see the hydrogen, everything, that is the pressure. So you don't need to go and pump the water from underground to what? To get the hydrogen. So the water pressure is coming automatically.
Water fountain.
Yeah. Okay, it's not man-made water fountain. Okay, it's a natural water fountain. Okay, so that is because of the confined under pressure. Okay, so okay, here there's a recharge and discharge. Okay, you see, groundwater recharge is any water added to the aquifer. Aquifer. Okay, so how? Groundwater recharge. What is groundwater? Underground. Recharge means when you recharge means you put. Okay, you recharge your phone. Means that you adding, correct or not? Adding. So means that what is groundwater recharge? What are the source of groundwater recharge? Rain. Okay, rain is a groundwater. One of the examples of groundwater recharge. And also, there's some other things like, for example, leakages, like reservoirs, lakes, aqueducts, and artificial injection. In some places, water will be injected. Okay, water will be injected into the underground through the the injection system, like how they dig the petroleum. So water will be injected. That is, you adding water to the underground. That is the recharge. Groundwater discharge means water coming out. Recharge going inside. Discharge means removing or coming out from the underground. So these two terms you just remember. Okay. Bioregulation. Here also same. In situ, ex situ. Okay. So in situ here. Bioventing, bioslurping, in situ, bio barrier. Very simple, these three methods. Okay. Bioventing is what? Venting is what? Vent. Vent means ventilation. Ventilation means air, right? Bioventing using air. That's all. Bioslurping. You take slurping?
Yes.
That's all, same concept. Same concept. You just like drink it. That's all. The contaminant suck from the underground. That's all. So you don't need to make it very difficult. You think about your daily life. Ventilation, so using air. Bioslurping, you drink slurpee, so it's like that, the same concept. Then in situ bio barrier, you put the barrier. Barrier, you know, right? Barrier. You form some kind of barrier, okay, between the contaminants and then the underground. That's all. That's the three methods. Okay. So you want to see more in depth? Okay. You see? Bioventing. So stimulating the natural in situ biodegradation petroleum microorganisms by providing oxygen to the existing soil microorganism. So you see, if the soil is contaminated underground, like for example contaminated with any petroleum or any fuel, everything, so they inject this oxygen. So inject the oxygen so that what the microbes under the soil get the oxygen to degrade the contaminants. That's the okay. So you can see the oxygen concentration in the soil increased by injecting air into the contaminated zone through drill wells. Okay, uses low air flow rates to provide only enough oxygen to sustain microbial activity. That's all. What is the purpose of oxygen? For the microbial activity. Okay. So some also they using the enzyme. Okay, that is what we call it co-metabolic. Co-metabolic bioremediation is the breakdown of a contaminant by an enzyme or cofactor that is produced during microbial metabolism of another compound. So they using oxygen and also some cofactor produced from microbial activity. Okay, so that is why they call it co-metabolic bioremediation. Okay, so this one also used for the volatile organic compound and this one lah, only volatile organic compound. Volatile organic compound. Okay, and limitation: presence of water table close to the surface can reduce bioventing performance. Okay, low soil moisture. Okay, these are the main limitations. Okay, low soil moisture contain may limit biodegradation. Okay, and aerobic biodegradation of many chlorinated compounds will not be effective unless either a co-metabolite is present or anaerobic cycle is used. Okay, these are the limitations for the bioventing system. Okay, and for this system, heavy metals cannot be treated. You give the oxygen for the microbe, but the microbe cannot treat the heavy metals. So the heavy metal cannot be treated in this bioventing system. Okay. Okay, bioslurping. You see, same. It's a much like straw drawing liquid from glass. Same method. Okay. So the pump draws liquid, LNAPL and some groundwater and soil gases. Okay, up the tube. That's all. That's the method. So you can see it's like a straw. Okay, it's like a straw. So it combines bioventing and vacuum and us pumping to recover light non-aqueous waste liquid such as oil of the top of the water table and from the capillary. So any contamination, just take from the pump like a straw. That's bioslurping. Okay. So it depends lah. The depth and everything you can adjust in this bioslurping method. So it is used for LNAPL. Remember, this is the application for LNAPL. Help to remediate non-halogenated volatile organic compounds. These two type of applications. So limitation: since the fuel, water, and air are removed from the subsurface once in mixing of the phases might occur. So this mixture may require special orbitals to separate, to treat these contaminants. Okay, so if you analyze all the method, okay, if you do one table and see, most of the problem is to treat the contaminants. So after they treat the contaminated soil, contaminated underground water, to treat the contaminant is one of the limitations. Okay. Okay, the last one, the in situ bio barrier. So you can see the bio barrier here. This is the barrier. Barrier means something you think about barrier. Barrier is like something, a wall or something. Okay, you just form a barrier. It's an engineered system where a barrier is created in the path of the plant, contaminated groundwater, through injection of electron donor, electron acceptor or nutrients. So it is a containment method that prevents further transport of the plant. So same thing. The contamination is moving underground water. So you just put some barrier to block the movement of the contamination. That's all. Okay. So in the barrier, microwave processes are induced to degrade the pollutants in the groundwater while it flows through the barrier. Okay, no pumping is involved. Like the bioslurping, the bioventing, no pumping is involved. Okay, it's a very simple method. Okay. Biobarrier filling materials are usually pumice, granules, quartz sand, perlite, inert sand, and etc. Okay. So this is the in situ biobarrier method. So it's used for what? To treat groundwater contaminated with mobile contaminants. Okay, mobile contaminants, volatile organic compounds. Okay, and limitation only works with biodegradable pollutants present in groundwater. Okay, not suitable for groundwater contaminants situated in subsurface 50 meter. Okay, due to technical and budget issues. Okay, human cannot go very deep to the underground. Okay, clear. Totally 9 method, bioremediation method. Too much. And maybe I just give one question. Explain bioremediation method. To explain all the 9 methods. Okay? Can I? Okay? So for here, what are the important things? Same thing. Okay? Same thing. Okay? Just 3 methods. Okay? Definition of the method. What is the method? But don't explain like what I explained now. Just listen. The method is like drinking slurpees. Don't explain like that. Okay? I just explain like that so that you can remember how the method works. Okay? But you explain the proper definitions. Okay? And of course it's the limitations. What are the contaminants? What are the limitations? Just 4 things. What's the method? Limitation. What contaminants? What limitation? For each point you have. Okay? That's all. Okay. Or you want to continue next time? Too much anyway. Okay. So, anything else? So I will set together composting and display all 3 lectures.